when we're working with identities, there are going to be lots of different methods that we could use to evaluate, solve, simplify different identities. But there are going to be certain methods that are a little bit more common than others, and I want to highlight some of those with the examples that you're going to see here. First method, and this is the reason this is method number 1 is because this is the most important method that you'll be using probably throughout all of chapter 5, is we want to, if we're going to simplify these expressions, we want to change these expressions into ones only involving sine and cosine. So we're going to see some examples here where they can all be changed in that way, and I've got some of the identities that we'll be using around here. There are also the reciprocal identities, which you saw on this sheet, or if you have your identities page, you'll see these reciprocal identities as well. We'll be using those quite a bit too, but just this page right here again is going to be a lot of what we do in 5.1 and 5.2. So we start with this one. Number 1 is let's decide how we simplify cotangent of x times the sine of x. Now there isn't necessarily one right way to do it, but it's probably going to come out in a certain way in the end. Now cotangent, if you look down here, cotangent with the quotient identities is the same as cosine over sine. So our method here is to get everything involving sines and cosines. So I'm going to replace that with cosine of x over sine of x. Sine of x right here, that stays where it is. And so now we have an expression where you can probably see already that the sines can be canceled out, and we just get cosine as the final simplified version of this. So cosine of x is what that all amounts to. And this one is, you can probably agree with me that that is much simpler than the original statement. All right, so that's the first one. Next one is we've got a little bit more of a complicated process here. You'll see we have sine and we have tangent, cosine of pi over 2 minus x. Now we need to change things to be in terms of sines and cosines, at least on this page. And so sine here is okay. We'll have sine of x. Tangent is this right down here, so we can replace that with sine over cosine. And then cosine is already cosine, so we'll just leave that as is. But then over here we've got a cosine, but it's kind of nasty. We've got pi over 2 minus x, and so we don't want that necessarily. We want to use one of the cofunction identities to change that, and it looks like in this case we got cosine of pi over 2 minus x. That's the same thing as sine of x, and so we'll replace this with sine of x. Now once we have that stuff taken care of, you might notice that there is one thing here that can be simplified. We can cancel out in this second expression. We can go cosine and cosine canceled out. Now what we have left is just all sines. We have sine x minus sine x, which is just 0. But then we have plus sine of x, so that puts it back in, and so we just are left with sine of x when all is said and done. So that's also, as you can probably agree with me, much simpler than the original expression. Last example on this page, we have cotangent of negative x, cotangent of pi over 2 minus x. This is going to sample from the cofunction and the even-odd identities. Let's start with cotangent of negative x. We're not going to necessarily put that in terms of sines and cosines just yet, but this negative on the inside is pesky. It doesn't work well for us. We don't like to see negatives, or pi over 2 minus. We don't like to see that kind of stuff inside the parentheses, and so we're going to change that. First of all, cotangent of negative x is the same thing as negative cotangent of x, and we'll take care of that here in a little bit. And then cotangent of pi over 2 minus x, that is the same as tangent of x based on this one right here. So we use this one and we use this one, and now once we've got those substitutions, these are a lot simpler to work with. Now we can go back to the quotient identities like we had before. Cosine over sine is the same thing as cotangent, so I'm going to leave the minus out on the outside, so that's cosine over sine. And then tangent can be replaced by this one, sine over cosine. So we've got this expression. And now, when we get those all lined up, you'll probably notice right away that we have some cancellations we can do. We can cancel out sine on top and bottom there. We can cancel cosine out top and bottom there. And it leaves us with, well, it seems like nothing, but it's actually just a 1. There's a negative out in front, and so this ends up being -1, and that's certainly simpler than the expression that we started with. So this is an example of, these are some examples of using the sine cosine change. I'll refer to that a lot throughout the chapter, but this is the single most important way to use trig identities. If you're ever stuck on a problem, I would start with this one 90% of the time. There are going to be other examples that we go through, and you see other patterns, but this one is, to me, the most important method for working with trig identities.